Hello girls, we're back with another video. So odd and even functions. So I'm going to draw for you an odd function. And I'm going to draw for you an even function. What should my even function look like? It should look like this, I think. And I'm going to put a quiz question in here as to what you think a definition might be for an odd or an even function. Now, there's a few different ways you can describe this, and I'm actually going to talk about the even function first because it's a little bit more straightforward in my opinion. So there's two ways of describing an even function. The in many ways more mathematical way is to say that it's symmetric. Need to make it about the y-axis, so there is an axis of symmetry at the y-axis, but the way to prove it algebraically, which is especially important if you don't know how to draw it for some reason, is to say that f of minus x is the same as f of x. Now hopefully you can appreciate that these two things mean the same thing, right? If you pick an x value, oh my goodness, there we go. If you pick an x value, and you say what is the value of the function at that x value, right? That's f of x there, and then you take the same negative x value, what is the value of the function there? They should be the same. That is what it means to be symmetric, right? This point here should be reflected in this line, so these two distances should be the same. Okay, and we'll do some proving of that in a second. For an odd function, it's not quite as straightforward to define it geometrically, but the way to define it is often, people will say symmetric about the origin. Okay, so what I'd encourage you to do is draw this diagram on a piece of paper to understand why. So the idea is if you draw it and you, oops, what have I done? And you stick, come on, and you stick your finger there at the origin and you spin 180 degrees, the function should look exactly the same. It's got rotational symmetry about the origin. Right, what it means is that this segment here, if you rotate it 180 degrees, should be the same as this segment here. Okay, that is what it means to be symmetric about the origin, which tells you that all odd functions either must pass through the origin, because otherwise you can't be symmetric about the origin, or be undefined at the origin, right? Sorry, when x is 0. So for example, a hyperbola is actually an odd function, but doesn't pass through the origin, right? There's a hyperbola. You can imagine if you rotate it 180 degrees, it'll look identical. The algebraic way to prove it is to say that f of minus x is the same as negative f of x, right? And if you like, you can move the minus sign over there. It's actually easier to prove it this way, I think, right? Because basically what we're going to do is we're going to do all of this stuff on the left-hand side and show that it equals fx. Okay, and again, it's the same kind of idea. If you pick an x value over here, and you pick the negative of it over here, they should have the same size, but just be negative versions of one another, because this is going to be rotated 180 degrees to land there. Okay, and this must be true for the full domain of the function, otherwise it's not odd or even. So let's just do some examples and let's work out whether they're odd or even. So let's do one that I just spoke about, 1 on x. So because the question says is it odd or even, you don't really know how to approach it. So the way to do it is always just to start with f of minus x, because notice both of the definitions have an f of minus x in them. So in this case, f of minus x equals 1 on minus x, and I can pull the minus sign out the front, and that is negative f of x. So therefore, it is odd, rather than even, or in many cases, neither odd nor even. Okay. So as we said, what that means is that when I draw it, and often the reason we do this is to assist with our drawings, sketches, graphs, whatever you want to call them. When I draw them, if I know part of it, I can draw the other part using symmetry. Right? If for some reason I only knew that it was true to draw this bit, I could draw the whole function just by using symmetry. Another example? Why not? What better do we have to do than more examples? G of x. Oop. Oop. Oh, come on. There we go. That's x to the 4 minus x squared. So again, is it odd, is it even, is it neither? So we evaluate minus x of the function. Damn it. And I want you to think about, before I do anything else, right, what's going to happen is it's going to be even, perhaps. Perhaps. Maybe I just gave it away. But is there a general rule you could kind of generate for polynomials? In other words, things that are just powers of x, right? Because notice what happened here. All I really did was I said the power is even, so minus x to the power just becomes x to the same power. Maybe there's a general rule that I could have, right? So that's an even function. Let's go again. Oops, that's no. Should be squared there, right? So again, evaluate at minus x. So that's just 2x squared minus x at plus x plus 7, and that is not equal to hx, clearly, because of the plus in the middle, and it's also not equal to minus hx, because it has to be for all values of x in the domain, right? And, I mean, quite clearly, they both have a plus 7 at the end, so they're going to be different for different values of x. So therefore we say it is neither odd nor even, right? And that's valid as well. It tells us that when we draw it there is no symmetry. Right. I want you to have a look at the powers of x here. Okay. Notice that I put an x to the power of 0 next to the constant. That's a bit of a hint as to there's a rule about the powers of x and whether or not there's oddness or evenness there. I will tell you that rule in class tomorrow, but I want you to think about it tonight. You may have to remind me to tell you the rule though. I'm relying on you, please. Annika, you're going to tell me the rule. Remind me to tell you the rule. If not, Friday detention. Okay, one last thing. Bit more of a higher level style question perhaps. Prove that the sum of, I really hate writing word problems, of two odd functions is odd. Okay, so let's start with two odd functions. So let's say that we know that hx and gx are odd. So I'm going to evaluate h of minus x plus g of minus x, right? Because that is the sum of the two functions. In fact, maybe I should be a bit more prescriptive. So let's say fx is the sum of hx and gx. That's a much more sound mathematical way of proof. So we're evaluating f of minus x. And in fact, I'm going to evaluate minus f of minus x because I'm showing that it's odd. So I'm going to use this and show that this is the same as fx. It's generally easier. So minus h of minus x plus g of minus x. Right, apply the fact that both h and g excuse me, are odd. Multiply through by the minus signs. That is fx. Therefore, it is odd. Oops. Right, just like us. Bravo us. Okay, that's all for tonight. I want you to notice for me as well, though, that set F and set G we've actually done through various parts of our studies this term. So that is not something I will directly address either in these videos or in class. So that is just something for you to go away and work through on your own if you feel you need it. Okay. You'll also notice there's some stuff in the book explaining how to use a graphics calculator for some things that you might find helpful. Alright, have a terrific Wednesday night. Tomorrow, but tonight you should have a terrific Tuesday night, and I'll see you tomorrow on Wednesday.